This video is not going to cover some topics that really are the main kinds of things that's going to be taught in a calculus class. A lot of the stuff we have gone over up until now is really more algebra based, but the kinds of things we're going to look at now are the kinds of things that you use calculus to determine. And of course, once again, we're going to look at it from a graphical perspective. And once we cover this material in the actual calculus class, we will do it mathematically, but also graphically. But I want to do it graphically just to help you see the big picture of what we're going to be learning in calculus, so that when we get to that point, it'll be very clear what we're doing. So here's something that is a big part of what we learn to determine in calculus. When you have a function, oftentimes you're asked to find the maximum or the minimum. I'll even put here values of the function. I'll just do f of x. The maximum or minimum values of f of x of the function. And this is actually why in calculus, there's lots of story problems in calculus that may not make some of you very happy, because usually students don't like story problems, but story problems are very prevalent because a lot of times you'll be given some kind of situation, some type of science problem or some kind of business problem, and it's pretty common that the goal of the problem is to find the maximum or minimum of something. Now, let me say this from the start. In the world of math, there are sort of the proper and complete way to say things, and then there's sort of a shortcut. So actually what we're going to be looking at, even though when I teach this and even in this video, we will be talking about maximums and minimums, to be really absolutely careful and correct. We should say that we're going to be looking at the relative maximum and relative minimums. I'm not going to use these words very much because I think in the context of what we're doing, when I say maximum, minimum, it'll be very clear. But in terms of the literal sense, the technical sense, we're looking at relative maximums and relative minimums, because the other kind of maximum and minimums, and we will look at these in calculus, there will be times when we're given problems and we'll be asked to find the absolute maximum. I'm not going to really cover this in this video, but this is also something that is a part of calculus. But the big part of calculus is really learning how to find these relative maximums and minimums. So let me explain the idea of maximum, minimum. And then there's one other concept I want to cover. Then after that, I've printed out a bunch of graphs of functions once again. And then we can simply look at those graphs and then determine these points of interest that we're learning about. Just to sort of make it simple, when we're looking at the graph of a function, and we're asked to find the maximum. And just so you know, a function can have more than one maximum. It could have two maximums. It could have two minimums. But just in terms of the concept, and you won't find this very hard, but let me tell you how I like to think about a maximum, just in case someone isn't very clear on it. When I think of a maximum, I think of, here's the phrase, top of a hill, and for the minimum, the bottom of a cup. All right, this is going to be a very easy concept. So if I have a graph like this, if I'm given this graph and I say, find the maximum or minimum, the maximum just means, where on this graph is the highest point. So in a sense, you could see that as we move, and as you look at functions and graphs, you always move from left to right. So moving from left to right, you can see we're going up, the function's increasing, the function's increasing, it keeps going up. And then somewhere, way at the absolute highest point of this graph, sometimes I call it sort of a hill, somewhere at the highest point, it's like you reach the maximum. It's almost like if you're climbing up a hill and you get to the very top, you've reached the maximum height of the hill. Okay, that's a maximum. Because as you keep moving to the right, then all of a sudden you're going down and the value of your function's decreasing. So you would say this point is where we have a maximum. And oftentimes you look for the value of x, and just for fun, I'll call this value of x. I'll put a little subscript. This is the value of x that gives us the maximum. And then here is sort of the actual value of the maximum function. In the same way, I won't take a lot of time to talk about it. Well, if you're given this and you're asked to find either the maximum or minimum, well, obviously you don't have a maximum, but the minimum is sort of like the bottom of the cup. The minimum is, as this function is decreasing, what's the absolute lowest point of this function? So that's the minimum. Now, here's what can happen. First of all, you can have something like this. If you were given this graph and you were asked to find or to locate any maximums or minimums, you would start here and you say, I'm going up, up, up. And you're saying, up, I get to the top here. It's like, and then I start going down. So you would say, anytime you have like the top of a hill, it's a maximum. So then as you continue to go to the right, it begins to function goes down. But then when you get to here, before you know it, all of a sudden the function is increasing again. So what's happened as the function's going down, once again, this is like a bowl or a cup. And say if the very lowest point is right here, and that's a minimum. So here's a case where in the same graph, the same function, we have both a max and a min. And then what if you had a graph like this? And you were asked just to find on this graph any maximums or minimums. Basically, you're just looking for, any points like this, like the top of the hill where it goes up and then comes down. So obviously it looks like that should be a max. And this should be a max. These are maximum points, so the two of them. And just as a sneak peek, absolute max would be the absolute highest point on the whole graph. Relative means in this area, since it goes up and then comes down, what is the relative max or min? So that's why it's easiest just to think. It's easiest just to think of like either a hill or a cup. So I got two maximums. What do we also have down here? This is like a bowl or a cup. So it looks like around here someplace we have a minimum. So actually in this graph, I have two maximums and a minimum. And later on, you'll see we will use calculus to actually determine the values of x for these two maximums and the minimum. And then we'll also use calculus to determine the value of the function at the maxes and the mins. All right, so that's a pretty straightforward concept, hopefully. And like I said, in a few minutes, we're going to look at some graphs, and we will look at maxes and mins. As a matter of fact, I actually might do it right now. There's another concept we're going to talk about, but I may hold off for now and go ahead and just go through some of these graphs I printed out and just pick out the relative maximums and minimums. So let me say this. So sometimes, almost always, when they ask where are the maximums, sometimes write it like this, max/minimum. So it says, where are the maximum and minimums? What they're really looking for are the values of x for the maximums and the minimums. And sometimes that's all they will ask you. So they're just asking you to find the values of x where you have a max and a min. But other times, they'll say, where are the maximum and minimums? They'll say, and determine the value of the function. So it's almost like in this first question, it's almost like they're looking for just the values of x. Just the value of x where you have maximums or minimums. The second question, you're going to find the values of x again, but for each x, you're also going to find the value of the function. So it's almost like the second question, you're finding the point here, the x and the value of the function. It's almost like you're finding the x and the y, the x and the y, the x and the y. This first question, all you care about is the value of x. Let's just look at some of these graphs, and we'll simply ask to figure out where the maximums and minimums are, and if possible, it will actually also try to give the value of the function. Here's a pretty straightforward, just so you know. Here's the equation we're going to graph. Y equals x squared plus 2, or f of x equals x squared plus 2. When you graph it, it looks like this. So here's your origin. Of course, the vertical axis is the function. Horizontal axis is your value of x. So simply the question is, find the maximum and minimums. Give the value of x at the maximum or minimum, and then also give the value of the function. Hopefully you can see pretty straightforward function graph. In terms of maximum and minimums, you always move from left to right. Looks like we got a minimum, and when you eyeball it, looks like it pretty much occurs right here. So you would say we have a minimum. And what's the value of x at the minimum? It's 0. And the actual value of the function, so the value of the function at this point, here to here is 10. Looks like there's 5 spacing, so each of these hash marks is 2. So it looks like the function at the maximum, whoops, I keep saying maximum. At the minimum, the function equals 2, and the value of x is 0. So that really means that that point right there, right, is 0, 2. The minimum is 0, 2. 0 is the value of x, 2 is the value of the function. All right. So let's go a few of these. You're going to find this real hard. We're going to look at the graph of this function, y equals 1/3 x minus 2. Now, if you're picking up, that's called a linear function. So if we look at the graph of it, lo and behold, it's just a straight line. Once again, here's the origin. The function's up and down. The across is the value of x. So now, as I move from left to right, I'm looking for any maximums or minimums. So it's interesting as I'm moving from left to right, it's increasing. It actually increases the whole time. And by looking at it, it's pretty obvious there are no things that look like a hill or a cup or a bowl, right? So if you were given this graph and said find the maximums and minimums, you would just say there are no maximums or minimums. And actually, the next graph is very similar. You'll see why later on why I also want to look at this one. Another linear equation. So therefore, also you look at the graph. It's a straight line. You go from left to right. There are no maximums or minimums. So once again, no maximum or minimum here. All right, this next one, just in case you're interested, here's the function we're going to graph. Here's what it looks like. It's actually graphed. So, same objective. Find any maximums or minimums, and when you do, find the values of x and the actual value of the function, if possible. So if you think about it, hopefully pretty straightforward, but just to make sure I'll go through it. So as I'm moving from left to right, I go up, you get to here, then it starts to decrease. So obviously, right here looks like we've got a maximum. Decreasing, functions decreasing, function, actually the function even goes negative, still decreasing. But then here it sort of bottoms out and then the function starts increasing. So therefore, that right there is a minimum. And it goes up and keeps going up. So for this function, I have both the maximum and the minimum. And it looks like sometimes when you have graphs, you can't always tell exactly what the values of x are or what the values of the function are. But this one, I think I can make a pretty good guess. It's pretty clear. Maximum at x equal 1. And what's the value of the function at that maximum? Well, 10 to 20 here. So looks like each hash mark is going to be 2, right? 12, 14, 16, 18, 20. You can't tell for absolutely for sure, but it looks like this is pretty much halfway in between 16 and 18. So I'm going to make a pretty good guess. It looks like to me like the value of the function at the maximum is 17. So once again, just to be super clear and obvious, basically this point here, x is -1. The function or the vertical value of this point is 17. Now here's my minimum. What's the value of x at the minimum? Value of x is 2. So I have a minimum at x equals 2. So what's the value of the function at the minimum? When you look here, here's a minimum. The value of the function is -10. So at the minimum, the function is -10, and then just to be very obvious, if I were to think of that as a point, it's 2 minus 10. All right. Hopefully you're getting this and realizing this is not too difficult. A few more graphs to look at, and then we'll move on to the second topic I want to cover. Is that of interest? Here's the function we're graphing. And when I go to my little online program, it looks like this. I print it out. Looking for maximums and minimums. It's pretty clear down here. Looks like I've got a minimum. Comes up here, looks like a maximum. Down here, another minimum. So for this function, let's have two minimums and one maximum. So let's do minimum at, let's do them one at a time. Minimum at x equals -1. And at that minimum, the value of the function is -1. The second minimum is at x equals 1. And the value of the function for this minimum is -1. Finally, here's my maximum. Looks like the maximum occurs when x is 0. This is actually my origin right here. This maximum is actually at the origin. So the maximum is when x equals 0. And what's the value of the function at that maximum? It's also 0. All right, a couple more. Maybe this last couple of graphs have a little bit of a twist to it or something different. Pretty sure you're probably getting the hang of this. I'm going to graph this. All right, remember this is like a rational expression. Looks like a fraction, right? A lot of times when we graph rational functions, we have a break or a gap. And we do here. It's like there's two parts to this graph, two parts to the function. We probably, if wanted to, could have drawn in a vertical asymptote at x equals 2 and probably a horizontal asymptote at y equals 1 or the function equals 1. But for our purposes, it's not really what we're looking at. We're trying to find any max or mins. Start to the left of the graph. It's like it's just decreasing steadily, and then it starts decreasing pretty quickly, and it just keeps decreasing. So if you look at this part of the graph, if I'm looking for something that looks like a hill, where it's going up and coming down, or a bowl or a cup, it's like neither one of those. This just goes down the whole time. So for this part of the graph, there's no max or min. And I come over here and I jump and start once again heading to the right. So it's decreasing, decreasing, actually it's decreasing the whole time, which once again means that there is no maximum or minimum here. So here's an example of a graph of a function with no maximums or minimums. And that happens sometimes. And the last one, once again, it's the graph of a rational function. So we got a fraction going on here. So here's, so I can't fit the whole graph on the screen, but sort of move it up and down a little bit. So here's your origin. It's sort of interesting. It sort of comes up at an angle, and then it looks like it hits a peak. It looks like I've got a maximum, then it drops off really quickly. And then when you pick up the graph again, it's dropping really quickly, and then all of a sudden it starts to turn around and begins to go up again. Hope it's pretty clear. Looks like that point's going to be a maximum, and this point is going to be a minimum. And if they ask us to try and attempt to give the actual values, I would say at sort of this maximum, looks like x is equal to 0, and the actual value of the function looks like it's a -2. I should say this is a maximum. The minimum is right here. Looks like it occurs when x is 2. And the value of the function at the minimum looks like 2. And there you go. All right. So to look at a graph of a function and to find the maximum or minimum, this is pretty straightforward. Now, just so you know, all the graphs I've chosen, it's very easy to determine the max or min. I should have had a graph where it's not, just to give you an idea that sometimes looking at graphs, you can't always give the, maybe for the next video, when I start, I'll give you an example of having a max or min when you can't always accurately pick out the value of x or the function. These, I made it so we could, because I want you to understand max and mins, but problems you have in the future may not be so clear cut. Anyway, so that's maxes and mins, and the next video will be on looking at where functions are increasing and decreasing, which is another way to talk about the slopes of functions. You've probably heard that word before in math, so we're going to talk about it again, the slopes of functions.